In an era defined by rapid technological advancement and an ever-expanding understanding of our universe, NASA continues to stand at the forefront, pushing the boundaries of discovery, grappling with the complexities of orbital mechanics and navigating the evolving landscape of societal values. Recent developments highlight this multifaceted role, from unraveling ancient Martian mysteries to an unexpected burst of energy from a long-dead satellite and a critical discussion on the agency's commitment to diversity. One of the most intriguing recent insights into our cosmic neighborhood comes from Mars, where the Curiosity rover, building on observations by the Opportunity rover in 2004, has helped astronomers further understand the enigmatic Martian spherules. Dubbed blueberries due to their small spherical shape, typically about 4 mm across, these iron and rock formations were found embedded in and surrounding rocks, notably at a site called the Berry Bowl. According to a recent Astronomy Picture of the Day APOD feature analysis by Opportunity of the underlying rock composition, which differed significantly from the hematite-rich spherules, contributes to a growing consensus that these small strange gray orbs were slowly deposited from a bath of dirty water. This finding is crucial for piecing together the hydrological history of Mars and its potential for past habitability, painting a picture of a planet once much wetter than its current arid state. The APOD itself is celebrating its 30th anniversary, a testament to its enduring role in public science education. Closer to home, Earth's orbital environment delivered a surprising jolt last summer when NASA's experimental Relay 2 satellite, a communications craft launched in the 1960s and considered defunct since 1967, suddenly emitted a super-short, powerful burst of energy. Researchers at Australia's Curtin University, using the Australian Square Kilometre Array Pathfinder ESCAP radio telescope array, detected a signal so loud it briefly outshone everything else in the night sky. Clancy James, a Curtin astronomer, described his initial shock, thinking they might have discovered a new pulsar. However, the signal's proximity to Earth meant ESCAP's telescopes couldn't all focus on it simultaneously, leading them to trace the source to the derelict Relay 2. While the exact cause remains a mystery, two primary hypotheses are being explored: a collision with space debris or a massive electrostatic discharge resulting from a long-term buildup of electricity within the satellite. As astrophysicist Karen Aplin of the University of Bristol noted, this detection could offer a new technique to evaluate electrostatic discharges in space, a crucial capability given the increasing congestion of Earth's orbit with space junk and smaller, less protected satellites. This unexpected event underscores the dynamic and sometimes unpredictable nature of our orbital environment, highlighting the need for continuous monitoring and advanced space situational awareness. Beyond the scientific and technical marvels, NASA's public image and internal values are also under scrutiny. A recent opinion piece in Florida Today by guest columnist John Crosby argued passionately that diversity, equity, and inclusion has always worked for NASA. Crosby recounted a visit to the Kennedy Space Center's Heroes and Legends exhibit, which emphasizes not only American achievements but also international collaboration with scientists and astronauts from 20 countries. He lauded the exhibit's focus on universal characteristics of heroism, inspiration, curiosity, tenacity, passion, courage, confidence, selflessness, discipline, principles, and the prominent display of astronauts of color, including Gayon Bluford, the first African American in space, and Franklin R. Chang Diaz, the first Hispanic American. Crosby's strong opinion piece directly criticized recent reports, notably from Ars Technica, suggesting that the White House has reneged on pledges to include a black astronaut and a female astronaut on the initial Artemis missions to the Moon. He condemned such actions as blatantly racist and misogynistic, asserting that space exploration thrives on the collective effort of the entire human race and that NASA's historical commitment to DEI at its core principles is something to be celebrated and expanded. This debate underscores the ongoing tension between scientific ambition and evolving societal expectations, particularly in an agency that serves as a global beacon of innovation and human endeavor. In a broader sense, NASA's capabilities extend beyond deep space and human exploration, playing a vital role in Earth observation. While a recent headline from Union Rio provocatively claimed a new NASA discovery of something we've never seen before that was neither known galaxies nor common stars, the article's content clarified this as a discovery confirmed by NASA satellite images, a strange tricky plant spreading uncontrollably in jungles and threatening tropical biodiversity globally. This highlights NASA's crucial albeit less publicized contribution to environmental science and biodiversity monitoring using its advanced satellite technology to track changes on our own planet. Taken together, these recent events paint a comprehensive picture of NASA as an agency operating on multiple frontiers. From deciphering the ancient geology of Mars to managing the complexities of space debris, and from championing diversity to monitoring Earth's ecosystems, NASA continues to shape our understanding of the universe and our place within it. The path forward will undoubtedly involve further scientific breakthroughs, unforeseen orbital challenges, and an ongoing commitment to fostering an inclusive environment that reflects the diverse world it serves, ensuring that the spirit of exploration remains a truly global human endeavor. The relentless march of discovery and the intricate dance of human ingenuity in the cosmos continue to shape our understanding of the universe and our place within it. From the delicate balance of orbital mechanics to the profound geological mysteries of distant planets and the pressing environmental concerns on our own world, recent developments underscore the multifaceted nature of space exploration and Earth observation. In a significant development for ongoing human presence in low Earth orbit, a leak on the International Space Station ISS has led to the delay of the eagerly anticipated SpaceX Axiom 4 astronaut launch, according to reports from June 22, 2025. This incident highlights the complex operational challenges inherent in maintaining humanity's longest-running orbital outpost. The ISS, which has been continuously crewed for decades, is one of two active space stations currently circling our planet. The other is China's Tiangong Space Station TSS, launched in 2021, which has rapidly expanded with the addition of modules like Wendian and Mengtian and achieved continuous human presence with its Shenzhou 14 crew in 2022. These orbital laboratories serve critical functions, supporting crew members for extended periods and facilitating groundbreaking experiments in microgravity, from studying human physiology in zero gravity to drug synthesis and disease research. As of 2023, a record 17 people were simultaneously in space, with 6 aboard the TSS, underscoring the growing global footprint in orbital habitation. The ISS, the larger of the two, has been in orbit for over 23 years, with its construction commencing in 1998. It has welcomed 251 astronauts from 20 different countries, a testament to international collaboration in space. Its remarkable longevity is maintained by a delicate balance between Earth's gravitational pull and the station's orbital velocity, a principle rooted in Sir Isaac Newton's laws. Despite orbiting at an altitude of 402 kilometers within the thin thermosphere, the ISS experiences atmospheric drag, causing it to lose approximately 100 meters in altitude daily. To counteract this, its thrusters are fired monthly to boost it back to its intended orbital height, a critical maneuver preventing its eventual uncontrolled re-entry and burnup. NASA has committed to operating the ISS safely through 2030, after which a controlled deorbiting is planned, marking the end of an era for this iconic space habitat. Beyond the operational intricacies of orbital outposts, the spirit of scientific inquiry continues to unveil the universe's secrets. On Mars, the robot Opportunity rover, which landed in 2004, made a fascinating discovery: thousands of unusual gray spherules dubbed blueberries, composed of iron and rock. These tiny orbs, averaging about 4 millimeters across, were found embedded in and surrounding rocks, particularly in a distinctive indentation named the berry bowl. Data obtained by Opportunity, including analysis of the surrounding rock's composition, supports the growing scientific consensus that these strange spherules were slowly deposited from ancient dirty water. This discovery, featured by NASA's Astronomy Picture of the Day (APOD) on June 22, 2025, continues to inform our understanding of Mars's watery past. Coincidentally, APOD itself is celebrating its 30th anniversary, a milestone that will be marked by a free public lecture in Cork. Ireland on June 24, underscoring the vital role of public outreach in sharing astronomical wonders. While humanity extends its reach into the cosmos and delves into the geological history of other planets, the focus also remains firmly on Earth. New data from NASA is prompting scientists to sound the alarm on escalating climate extremes. This critical information gathered through advanced Earth observation satellites and research highlights the urgent need for a deeper understanding and proactive measures to address the profound changes impacting our home planet. The recent news cycle encompassing an ISS leak, the vital role of active space stations, the geological revelations on Mars, and the pressing climate concerns on Earth paints a vivid picture of humanity's ongoing journey of discovery and adaptation. As we push the boundaries of space exploration and expand our presence beyond Earth, the knowledge gained from these endeavors, whether it's understanding Martian hydrology or monitoring our own planet's health, remains interconnected, shaping our future and informing our stewardship of both our home world and the broader cosmos. The path ahead will undoubtedly feature continued advancements in space technology, the potential for new orbital habitats, and an ever-deepening commitment to safeguarding our planet against the challenges of a changing climate. The intricate ballet of space exploration continues to unfold, showcasing both the formidable technical challenges inherent in pushing humanity's boundaries and the profound, inspiring impact of these endeavors closer to home. Even as the commercial space sector grapples with the complexities of orbital mechanics and hardware readiness exemplified by the latest delay to Axiom Mission, 4 communities across the globe are celebrating tangible connections to the cosmos. The Axiom Mission 4 Ax-4. The 4th private astronaut mission destined for the International Space Station ISS has once again seen its launch rescheduled, now targeting no earlier than June 22, 2025. This latest postponement stems from a critical leak detected and subsequently repaired in the aft segment of the ISS's Russian Zvezda service module. The decision to defer the launch, a collaborative effort between NASA, Axiom Space and SpaceX, underscores the paramount importance of crew safety and orbital infrastructure integrity. Originally slated for May 29, the mission has faced a series of delays, successively pushed from June 8 to June 10, 11/19, and now to its current June 22 target. The crew is prepared to lift off aboard a SpaceX Falcon 9 rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida, at a site synonymous with historic spaceflight. Confirming the revised timeline, the Indian Space Research Organization ISRO stated on X that teams from at Israel, Poland, and Hungary engaged in a detailed discussion with at Axiom Space regarding the probable launch timeline of Axiom Mission 4. This was followed by consultations with NASA and SpaceX to assess multiple readiness parameters, including the Falcon 9 vehicle Dragon spacecraft, the status of Zvezda module repairs, ascent corridor, weather conditions, and the health and preparedness of the crew in quarantine. Union Minister of State for Science and Technology Jitendra Singh echoed this, confirming on X that Axiom Space has indicated that June 22, 2025 may be the next likely launch date of Axiom 04 mission, carrying among others the Indian astronaut Shubhanshu Shukla to the International Space Station. The Ax-4 mission itself represents a significant milestone in the burgeoning era of commercial spaceflight and international collaboration. It will be commanded by Peggy Whitson, a veteran former NASA astronaut and now director of human spaceflight at Axiom Space. Joining her on the SpaceX Dragon spacecraft are 3 other distinguished astronauts: Shubhanshu Shukla from ISRO, who will serve as the mission's pilot and is set to become only the second Indian to journey to space after Rakesh Sharma's pioneering 1984 mission; Sław Uznański-Wisniewski, a Polish project astronaut from the European Space Agency ESA, and Tibor Kapu from Hungary. Both Uznański-Wisniewski and Kapu will serve as mission specialists. This mission notably marks the first government-sponsored human spaceflight for India, Poland and Hungary since the 1980s, highlighting a significant shift in national space strategies towards private sector partnerships. Once aboard the ISS, Shukla will conduct pioneering experiments related to food and space nutrition, developed through a collaboration between ISRO and the Department of Biotechnology with support from NASA. These experiments are crucial for enhancing understanding of sustainable life support systems, a vital component for future long-duration space travel. While the focus remains on the intricate preparations for human spaceflight, the broader impact of space exploration continues to ripple through communities, inspiring future generations. A poignant example of this outreach recently unfolded at Bernardston Elementary. The school celebrated the planting of a special NASA moon tree, an event graced by the presence of a former astronaut. These unique trees, grown from seeds that have journeyed into space, serve as living reminders of humanity's lunar ambitions and symbolize the enduring connection between scientific endeavor and public engagement, particularly among young learners. Such initiatives play a vital role in fostering an early interest in STEM fields, directly contributing to the pipeline of future scientists, engineers, and astronauts. These two seemingly disparate events, the meticulous high-stakes preparations for a commercial crew launch and the celebratory planting of a symbolic moon tree, together paint a comprehensive picture of the contemporary space landscape. It's a field characterized by both the formidable technical challenges of pushing humanity's boundaries beyond Earth and the profound tangible efforts to ignite curiosity and inspire the next generation of explorers and innovators. As the world awaits the launch of Axiom Mission 4, these developments reinforce the collaborative, ambitious, and ultimately inspiring trajectory of space exploration in the 21st century, promising further breakthroughs in science, technology, and human endeavor, even as humanity pushes the boundaries of cosmic discovery, uncovering long-held secrets on distant worlds. The very engines of this exploration face significant headwinds. Recent reports highlight both the thrilling advancements in planetary science and the stark realities of funding challenges that could impede future breakthroughs, creating a poignant contrast in the landscape of space exploration. A groundbreaking new study published on May 3, 2025 in Communications Earth and Environment has unveiled what scientists are calling a hidden in plain sight volcano on Mars. Dubbed Jezero Mons, this ancient volcanic structure sits right on the rim of Jezero crater, the very landing site of NASA's Perseverance rover since February 2021. For years, the feature, roughly 13 miles 21 kilometers across, nearly half the size of the 28-mile 45 kilometers wide Jezero crater itself, was simply considered a regular mountain. However, a meticulous re-evaluation of data, both old and new, has revealed its true fiery origin. This discovery is more than just a geological curiosity, it offers a crucial piece of the puzzle for understanding Mars's past habitability. Scientists had been puzzled by the unexpected presence of volcanic rocks on the crater floor, which was largely expected to be covered in sedimentary layers due to its history as a vast lake billions of years ago. The existence of Jezero Mons provides a compelling explanation. As James Ray of Georgia Institute of Technology, who first suspected the mountain's volcanic nature back in 2007, explained, "I was looking at low-resolution photos of the area and noticed a mountain on the crater's rim. To me it looked like a volcano, but it was difficult to get additional images." The new study, spearheaded by lead author Sarah Quavesky-Nonis, formerly at Georgia Tech and now at Brown University, combined data from multiple orbital spacecraft, including the Mars Odyssey orbiter, Mars Reconnaissance Orbiter, and ExoMars Trace Gas Orbiter, alongside observations from the Perseverance rover itself. Ray emphasized the value of this approach, noting, "I think this shows that these older spacecraft can be extremely valuable long after their initial missions end. These old spacecraft can still make important discoveries and help us answer tricky questions. The implications for the search for ancient microbial life are profound." A volcano adjacent to a former lake could have provided the essential subsurface hydrothermal heat, creating a potentially warm and chemically rich environment conducive to life. The coalescence of these two types of systems makes Jezero more interesting than ever, Ray stated, highlighting the potential for finding both incredible sedimentary rocks that could be from a habitable region alongside igneous rocks with important scientific value. This follows the recent discovery last year of another colossal previously unrecognized volcano in eastern Noctis Labyrinthus, measuring an astounding 280 miles 450 kilometers wide and reaching an elevation of 29,600 feet 9,022 meters, underscoring that Mars's volcanic history may be far more extensive and complex than previously imagined. Yet this period of burgeoning discovery is shadowed by significant fiscal uncertainty. Reports from Cleveland.com and MSN on June 21 to 22, 2025 detail widespread protests against proposed NASA budget cuts for the 2026 fiscal year. In Cleveland, Ohio, over 80 protesters mobilized by the Washington, D.C.-based grassroots nonprofit Stand Up for Science lined East 9th Street to voice their opposition to the cuts, particularly those affecting the venerable Glenn Research Center. The proposed budget outlines a substantial 24% overall reduction to NASA's funding, with the Science Mission Directorate facing a particularly steep 47% cut. This directorate is the bedrock of NASA's non-human spaceflight research, overseeing critical programs in Earth science, which includes vital climate data collection and analysis, recently highlighted as sounding alarms on climate extremes, heliophysics, planetary science, and astrophysics. The American Astronomical Society has pointed out that this budget proposal appears to prioritize human spaceflight at the expense of these fundamental scientific endeavors. The impact on personnel is equally severe, with the plan calling for a reduction of full-time civil service staff at NASA Glenn Research Center from 1,391 in 2025 to a mere 837 in 2026, representing a significant loss of expertise and institutional memory. The tension between ambitious human missions and the foundational scientific research that informs and inspires them is not new, but the scale of the proposed cut signals a potentially damaging shift. While human exploration captures public imagination, it is the tireless work of scientific missions, like Perseverance's quest for ancient life on Mars or the Earth-observing satellites monitoring our changing climate, that fundamentally expands our knowledge and provides data crucial for our planet's future. The potential loss of momentum in these areas, particularly given the unprecedented discoveries still being made with existing assets and data, raises serious concerns for the future trajectory of space science and its benefits to humanity. The coming months will be critical in determining whether the pursuit of new frontiers will be matched by the sustained investment required to truly unlock their secrets. Mars, the enigmatic red planet, continues to yield its secrets, painting an increasingly vivid picture of a geologically dynamic world with a fascinating and potentially life-sustaining past. Recent revelations from orbiting spacecraft and intrepid rovers have unveiled ancient volcanic giants, clarified the origins of peculiar geological formations, and offered breathtaking new perspectives on familiar Martian landmarks, all contributing to our understanding of whether life once thrived there and how future human missions might fare. One of the most compelling recent discoveries centers around Jezero crater, the current exploration site of NASA's Perseverance rover. Scientists including James Ray from Georgia Institute of Technology and Sarah Cuevas-Quinones, now at Brown University, have identified a significant mountain on the crater's rim previously thought to be an ordinary peak as a likely ancient volcano. Dubbed Jezero Mons, the structure measures approximately 13 miles 21 kilometers across, nearly half the size of the 28-mile 45 kilometers wide Jezero crater itself. The findings, published on May 3, 2025 in Communications Earth and Environment, leverage a combination of old and new data from multiple orbiting spacecraft, including the Mars Odyssey orbiter, Mars Reconnaissance orbiter, and ExoMars Trace Gas orbiter, alongside observations from the Perseverance rover itself. This reclassification of Jezero Mons offers a crucial explanation for a puzzle that emerged early in Perseverance's mission: the unexpected presence of volcanic rocks on the crater floor, which scientists had largely anticipated would be sedimentary given its history as an ancient lake. I was looking at low-resolution photos of the area and noticed a mountain on the crater's rim. To me it looked like a volcano, but it was difficult to get additional images, Ray noted, reflecting on his initial suspicions back in 2007. The confirmed volcanic origin of Jezero Mons is particularly significant for the search for past microbial life. A volcano adjacent to a former lake could have provided essential hydrothermal heat, creating a potentially habitable environment. As Ray emphasized, the coalescence of these two types of systems makes Jezero more interesting than ever. This new understanding of Mars' volcanic landscape is not an isolated incident. Last year, another colossal volcano significantly larger than Jezero Mons was identified hiding in plain sight south of the planet's equator in eastern Noctis Labyrinthus, reaching an elevation of 29,600 feet 9,022 meters and spanning an impressive 280 miles 450 kilometers in width. Such discoveries highlight that Mars' volcanic history may be even more widespread and complex than previously assumed. Further evidence of Mars' watery past comes from revisiting earlier rover findings. The astronomy picture of the day from NASA recently highlighted the enigmatic Martian spherules, affectionately known as blueberries, first discovered by the robot Opportunity rover in 2004. These thousands of tiny iron and rock orbs, averaging about 4 millimeters across, were found embedded in and surrounding rocks near Opportunity's landing site. A key location dubbed the Berry Bowl, an indentation rich in these spherules, provided crucial insights. By analyzing the composition of the underlying rock, which differed significantly from the hematite-rich blueberries, Opportunity's data strongly supported the growing consensus that these small strange gray orbs were slowly deposited from a bath of dirty water. This geological evidence, alongside the potential for hydrothermal systems near Jezero Mons, reinforces the picture of a Mars that once hosted extensive water, a vital ingredient for life. Adding to the dramatic imagery of Mars, NASA's longest-running Mars orbiter, the 2001 Mars Odyssey, recently delivered a stunning postcard from the Red Planet. Captured before dawn on May 2, 2025, the image showcased Axiom Mission, one of Mars's well-known giant volcanoes, dramatically poking through a sea of early morning water ice clouds. This 20-kilometer-tall volcano, nearly twice the height of Hawaii's Mauna Loa, was captured from the planet's horizon for the first time by Odyssey. Jonathan Hill, Arizona State University's Odyssey Themis operations lead, expressed the team's satisfaction. "We picked Axiom Mission hoping we would see the summit poke above the early morning clouds, and it didn't disappoint." Such high-altitude images are invaluable for scientists, enabling them to track seasonal changes and weather patterns on Mars, information that could prove vital for planning future missions and even identifying potential water sources for future human explorers. These collective insights, from ancient geological formations to real-time atmospheric phenomena, underscore the ongoing scientific endeavor to unravel Mars's mysteries. The identification of previously unrecognized volcanoes fundamentally reshapes our understanding of the planet's geological evolution and its potential to have harbored life. Coupled with the continuing evidence of a water-rich past and the dynamic weather patterns observed today, each piece of the puzzle brings us closer to answering humanity's profound questions about our place in the universe. As NASA and its international partners prepare for future sample return missions and eventually human landings, the detailed geological and atmospheric data gathered by these robotic pioneers will be instrumental in charting the course for humanity's next giant leap. The Moon continues to capture humanity's imagination and technological prowess, with NASA at the forefront of a renewed push for lunar exploration. Recent developments highlight the multifaceted nature of this ambitious endeavor. Encompassing rigorous safety protocols for impending crewed missions, intricate technical preparations for future landings, the evolving landscape of commercial space ventures, and the enduring legacy of past lunar journeys. As NASA gears up for its first crewed mission around the Moon in decades, Artemis II's safety remains paramount. Launch teams from NASA and the Department of Defense recently concluded an intensive 2-day simulation of emergency rescue procedures off the coast of Florida near the agency's Kennedy Space Center. These critical rehearsals, which took place on June 11 and 12, 2025, focused on potential abort scenarios for the Orion spacecraft, both during a launch pad emergency and during ascent to space. Using test mannequins and a representative crew module test, article teams practiced a launch countdown followed by a simulated abort, demonstrating how Orion's launch abort system would propel the capsule to safety for a splashdown. Navy helicopters carrying U.S. Air Force pararescuers then deployed to retrieve the crew from the water, transporting them for simulated medical care. The following day, a similar exercise was conducted 12 miles east of Kennedy, simulating an ascent aboard with pararescuers jumping from a C-17 aircraft to reach the capsule. Lakeisha Hawkins, NASA's Assistant Deputy Associate Administrator for the Moon to Mars program and chair of the mission management team for Artemis II, underscored the importance of these drills, stating part of preparing to send humans to the moon is ensuring our teams are ready for any scenario on launch day. We're getting closer to our bold mission to send 4 astronauts around the moon. And our integrated testing helps ensure we're ready to bring them home in any scenario. These comprehensive simulations are vital steps in validating the integrated procedures across various teams, from Kennedy Space Center's launch team to Johnson Space Center's flight controllers. Beyond the immediate safety concerns of Artemis II, NASA engineers are already deep into the technical challenges presented by future missions, particularly the Artemis III lunar landing. Engineers at Marshall Space Flight Center in Huntsville have been simulating lunar lighting conditions, a critical factor for the precision landing intended for the Moon's south pole. The unique lighting environment at the lunar poles, characterized by extremely low sun angles and long deep shadows, presents significant challenges for navigation and visual perception during descent and landing. These simulations are crucial for developing and testing the guidance, navigation, and control systems that will enable astronauts to safely touch down in these previously unexplored resource-rich regions where water ice is believed to be present in permanently shadowed craters. While NASA meticulously prepares for its next crewed missions, the broader landscape of lunar exploration continues to evolve, sometimes with unexpected outcomes. A stark reminder of the inherent risks in lunar endeavors recently came to light when a NASA spacecraft orbiting the Moon photographed the crash site of a Japanese company's lunar lander. This incident, while a setback for the commercial entity involved, highlights the steep learning curve and technical complexities faced by all participants in the new lunar race. Such documentation by NASA's reconnaissance orbiters provides invaluable data for understanding mission anomalies and improving future lunar landing technologies, benefiting not just the private sector but the entire space community. It underscores the critical role of post-mission analysis in advancing the collective knowledge base for lunar exploration. Adding a touch of enduring legacy to the current space news, communities across the United States are celebrating their connection to the original Apollo missions. Bernardston Elementary School, for instance, recently held a ceremony to mark the planting of a NASA moon tree with a former astronaut in attendance. These moon trees are grown from seeds that journeyed to the moon aboard Apollo 14 in 1971. Their planting today serves as a tangible link to past achievements, inspiring new generations and fostering an appreciation for space exploration at the grassroots level. It's a powerful symbol of how the quest for the stars transcends scientific and engineering achievements, embedding itself in cultural memory and educational outreach. In essence, the current flurry of lunar activities reflects a dynamic and multifaceted approach to returning humanity to the moon. From the rigorous safety drills for Artemis II and the intricate technical preparations for Artemis III to learning from the challenges faced by commercial partners and nurturing public engagement through historical artifacts, every piece contributes to the grand mosaic of lunar exploration. These efforts are not merely about planting flags on the lunar surface, they are foundational steps in humanity's journey deeper into the solar system, with Mars firmly in sight as the ultimate destination for future crewed missions.